Good morning students, welcome to Bindu Dhadwal chemistry lessons. Our topic for today is isomerism and its types. So in organic compounds, when two or more compounds are having the same molecular formula but different physical and chemical properties, they are called isomers, and the phenomena is called isomerism. Isomerism can be divided into two categories: structural isomerism and stereoisomerism or space isomerism. When the compounds are having the same molecular formula but different structural formula because of difference in the arrangement of the atoms, then the compounds are called structural isomers of one another, and the phenomena is called structural isomerism. Structural isomerism can be further of the following types. Number one, chain isomerism. In this case, the difference in two compounds occurs on the basis of the length of the carbon chain. For example, we can see chain isomerisms in alkane, alkenes and alkynes. In alkanes, this compound has 4 carbon atoms, a chain of 4 carbon atoms, whereas its chain isomer has a chain of 3 carbon atoms and the 4th carbon is attached to the 2nd carbon of this chain. So this is normal butane and this is 2-methyl propane. These two are chain isomers of each other. Similarly, alkene having a chain of 4 carbon atoms and a chain of 3 carbon atoms both have the same molecular formula. This is but1-ene and this is 2-methyl-prop-1-ene. Similarly, alkyne, this is pentyne and this one is 3-methyl-but1-ine. Second type of structural isomerism is position isomerism. Here the difference arises on account of the position of the multiple bond or the position of substituent or functional group. So let us take a few examples. These two compounds have the same molecular formula, but the difference arises in the position of the double bond. This is but1-ene, this is but2-ene. The double bond lies in the 2nd carbon atom over here. Similarly, here the substituents are attached at 1 and 2 position. This is 1,2-dichloroethane. This is 1,1-dichloroethane. So the position of both the chloro groups are at carbon atom number 1, whereas here at 1 and 2 respectively. Similarly, we can have amongst aromatic compounds, we may have orthoxylene, metaxylene and paraxylene. 1,2-dimethylbenzene, 1,3-dimethylbenzene and 1,4-dimethylbenzene. These are position isomers of each other. Next type of isomerism is functional isomerism, where the difference arises on the account of nature of functional group. The molecular formula of CH3CH2OH and CH3OCH3 is same, C2H6 and O, but in this case the functional group is OH group, whereas this is ether. So the two are functional isomers of each other. Similarly, ketone and aldehydes having the same molecular formula are also functional isomers of each other. Also, alkynes and dienes are functional isomers of one another. Next type of structural isomerism is meta-isomerism, where difference arises on the account of nature of alkyl group around a functional group. For example, the functional group is ether. The two groups attached on either side are ethyl groups in this compound, whereas in its metamer there is methyl group on one side and propyl group on the other side. Both are having the same molecular formula. Similarly, there is another metamer where on one side we have methyl group and on the side we have isopropyl. Here it's normal propyl, here it's isopropyl. So these compounds are metamers of each other. We can also have metamers in ketones. Then next type of structural isomerism is tautomerism. So in tautomerism, the functional isomers exist simultaneously and in dynamic equilibrium. One can change into the other, and the other can change back to the first compound. For example, ketones and these compounds which are having a double bond and alcoholic group simultaneously are called enols. They are tautomers of each other, and the phenomena is called tautomerism. The difference arises in the migration of electrons and hydrogen atoms. Hydrogen atom from first moves on to the third atom, oxygen. Hydrogen will move here and the double bond will move here. So a double bond arises over here and O turns into OH. So this is having a double bond ene, and in functional group OH, that is ol, so it's enol, whereas this is an aldehydic group. We can also have ketonic group present in tautomers. So next type of structural isomerism is ring chain isomerism. So these two compounds have the same molecular formula. One is a chain compound, the other one is a ring compound. This is prop 1-ene and this one is cyclopropane. Similarly, prop 1-ine and cyclopropene also are ring chain isomers of each other. So this was the structural isomerism. We have different types of structural isomers: chain isomers, position, functional, metamers, tautomerism, and ring chain isomerism. Second type of isomerism is called stereoisomerism, also called space isomerism. The compounds have the same molecular formula as well as the structural formula, but they differ in the relative arrangement of atoms or groups in space. We can categorize them into three categories: geometrical isomerism. This type of isomerism is also called Cistrans Isomerism. This occurs in compounds having double bonds and the two groups attached to either side of double bond. If they are on the same side of double bond, the isomer is called cis isomer. If they are on the opposite side of double bond, for example, B is on the opposite side of B and A is on the opposite side of A, such kind of isomer is called trans isomer. So these are geometrical isomers to each other. The difference arises in the geometry of compound. Optical isomerism, the two isomers behave differently towards plane polarized light. If one compound is rotating the plane polarized light to the left, the other one is rotating the plane polarized light towards the right. More details we will cover on this topic in the next class, in +2 class. Then third category is where the position of groups attached on either sides of carbon attached to each other by single bonds is different. For example, in this particular compound, there's a single bond between these two carbon atoms, and the hydrogen attached to first carbon atom covers the hydrogen attached to the second carbon atom completely. So as a result, the second carbon is eclipsed by the first carbon atom. This kind of conformation is called eclipsed conformation for ethene. In contrast, another position is possible because this group can rotate about this single bond, so the hydrogen atoms can then shift their positions in such a way that the hydrogen atoms of the second carbon atoms are maximum far apart from the hydrogens from the first carbon atom. So this kind of conformation is called staggered conformation, because the movement of the groups is possible around a single bond, so one conformation can change into the other conformation. Now, based on the information that we have studied in this video, let us solve a few questions. So we are given two compounds. Which structural isomerism is exhibited by the pair? So this is a carboxylic acid, whereas this is an ester. So the functional group is different. Both have the same molecular formula, C2H4O2. So these two are functional isomers of each other, and the phenomena is functional isomerism. In this case, the first compound A has a double bond and an alcoholic group, whereas the second compound has an aldehyde group. So these are tautomers. They can exist simultaneously and in dynamic equilibrium. So the phenomena shown is tautomerism. This is but1-ene, whereas this compound is but2-ene. The difference arises on the position of the double bond. So this kind of isomerism is called position isomerism. This compound is 1-amino-propane or propane 1-amine, whereas this is propane 2-amine. So the difference is on account of position of amino group. So the compounds are showing position isomerism. Next question is, write all the structural isomers of the molecular formula C4H10O. So C4H10O can exist as alcohol as well as ethers. Let us find out the various structural isomers of alcohol first. So we can have a chain of 4 carbon atoms and OH attached to one position or OH attached to the second position. Then we can have a chain of 3 carbon atoms and OH attached to first position and a CH3 group attached to second position. So this is 2-methylpropane 1-ol. We can also have a 3 carbon chain with a methyl group attached to the second carbon and OH also attached to the second carbon. The compound is 2-methylpropane 2-ol. Then ethers, we can have 2 ethyl groups on either side. This is ethoxyethane. We can have a methyl group on one side and propyl group to other side. This is methoxypropane. We can also have methyl group on one side and isopropyl group on the other side. This is 2-methoxypropane. So these are the different possible structural isomers for C4H10O. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.